Imagine you are learning how to paint, and then you take those skills and become classic sculpture. So LLM do the same thing. They learn from one place and then use that knowledge to perform in a completely different domain. It's like being a pro in one thing and then showing it off in another. Source model is trained on a large data set of images such as ImageNet, and the target model is then trained on another smaller data set of images. Here, the target model use the knowledge that the source model has learned about the visual words to help it for image classification of the targeted dataset. Let's see different ways to transfer learning. First, you need to set up your tools, some Python libraries, then get your data and read it like a detective, which is going to solve some problems. So first, you need to install and import Python libraries. You can install Python libraries for transfer learning, such as TensorFlow and PyTorch. Then we have next step, which is download and read data. This step involves downloading the text data that will be used for training the model. Assalamu alaikum everyone. Welcome back to the interesting landscape of language models. Before proceeding next, let's recap the past discussions. Based on the previous sessions, we understand the basics of LLM. We have discussed the pre-training and fine-tuning, as well as we discussed the instruction fine-tuning. And now we are ready to understand another most important aspect of language model, which is transfer learning. Okay, there are a few things you need to have in your knowledge. You should be familiar with machine learning, natural language processing in Python programming. You must have a good knowledge of deep learning and data pre-processing. Let's talk about the objectives. We are going to discuss the transfer learning that is needed for pre-trained LLMs. Then we will see the transfer learning usage and goals. At the end, we will talk about a model that can tackle new challenges like a champion. Okay, here is the agenda for today. We will be going through this presentation with this agenda. We will discuss the basics of transfer learning, their needs and large language models, and then we will compare them with the traditional models. Then we will discuss some strategies as well as their applications and its overall working. Okay, let's understand the transfer learning at a high level. Imagine you are learning how to paint, and then you take those skills and become classic sculpture. So LLM do the same thing. They learn from one place and then use that knowledge to perform in a completely different domain. It's like being a pro in one thing and then showing it off in another. Let's begin with the simple example. If you start learning a lot of things for one job, and now you want to use it for another job, so transfer learning work in exactly similar manner. Here is the idea behind transfer learning is that the source model has already learned some general knowledge about the visual world. This knowledge can be further transferred to the targeted model, which can help the targeted model to learn faster and more efficiently. If you see the image source model is trained on a large data set of images such as ImageNet, and the target model is then trained on another smaller data set of images. Here, the target model use the knowledge that the source model has learned about the visual words to help it for image classification of the targeted dataset. Let's see different ways to transfer learning. Okay, the first one is fine tuning, and the second one is feature extraction. Fine tuning, in this technique, we actually use the target model, which is initialized with the weight of the source model. Then the target model is trained on smaller data set with the weights of the source model, and these are being updated. This allows the target model to fine tune the knowledge that it has inherited from the source model. Then feature extraction. So the source model is used to extract the features from the images and the target dataset. So these features are then used to train the target model. This approach does not require the target model to be initialized with the weights of the source model. Let's see why transfer learning is needed. Do you know how something new task, learning something new takes time, and transfer learning says why not use what you already know? These pre-trained models are like walking encyclopedia of the languages. So instead of starting from scratch, we tweak these model a bit and they become expert in new tasks. It saves time as well as energy, and we don't need a lot of data to train these models. Now let's see the comparison between traditional language model and transfer learning. So traditional language model methods are like starting over when you switch among different tasks. Transfer learning basically uh, considered as somehow smarter than the traditional language training. It's like taking your old skills and upgrading them for new challenges. In traditional machine learning, you often dig deep into the manual feature engineering. But with transfer learning, the focus on the learning features automatically. So it's somehow different from the traditional language training. Traditional machine learning is an isolated single task learning approach, but we know that the model is trained on a single task and it cannot be applied to any other task. On the other hand, transfer learning is a multitask learning approach. This means that the pre-trained model can be used to learn new tasks by fine-tuning the model on a smaller and labeled data set. So we know that the traditional machine learning basically require more training data than compared to the transfer learning. This is because the model is learning from scratch and it does not have any prior knowledge. Then transfer learning, on the other hand, can utilize the knowledge that the pre-trained model has learned from the target model. Now we are diving into the type of transfer learning. Transfer learning is a type where which is all about adopting the LLM language and a big scalable data set. Then we have inductive learning. It is an approach which is like transforming or transferring knowledge from one expert to another. Then we have domain adaptation. It is like passing a knowledge from a rich kid to a kid which has fewer resources. Then we have translingual learning. So here, if we think like language superheroes who can translate anything, so these models are working like that. Then we have multitask learning. So imagine if you are working and you are working many things, and this is model working in a similar manner to do many things at once. And then we have sequential learning. It is all about understanding the latest trends and shifting and different languages. Okay, let's see how does transfer learning work. Traditional machine learning is useful when a model is trained from scratch using a large language model and with a huge data set of labeled data. This can be time consuming as well as computationally expensive. So transfer learning works when a pre-trained model is used as the starting point for training a new model. This can be faster and more efficient, especially if the new model is smaller, is look like the pre-trained model. So transfer learning is more efficient way to train the machine learning models for image classification because it can leverage and utilize the knowledge that the pre-trained model has learned from the target dataset. This can be used to achieve better results with less training data and less time. Let's do it step by step. Okay, here is a step-by-step process. First, you need to set up your tools, some Python libraries, then get your data and read it like a detective, which is going to solve some problems. So first, you need to install and import Python libraries. You can install Python libraries for transfer learning, such as TensorFlow and PyTorch. Then we have next step, which is download and read data. This step involves downloading the text data that will be used for training the model. This data can be in any variety of format like CSV form or JSON file. So then next step is to pre-process the data. This step involves cleaning and formatting the text data so that it can be used by the model. In this way, we can remove stop word, we can eliminate and stem the words and tokenize the text. Then we have next step, which is loading pre-trained model. In this stage, you can load a pre-trained model such as BERT model or RoBERTA model. These models have been trained on a large data set of text data, and that can be used as a starting point for training of a new model. Then fine tuning is the next step. This step involves the fine tuning of a pre-trained model on text data that will be used for sentiment analysis. This involves adjusting the weights of the model so that it can better classify the text data. Then we have evaluation mode, where we can evaluate the performance of a model so that we can ensure the data set should not be used for training, which is already used in the data set used in training should not be used in testing phase. Okay, now you need to load the data frames, and this step loading pandas data frame, and that basically contain the text data. Next, you need to create the data set. In this step, you will be interacting with the Hugging Face data set from the pandas data frame. This involves specifying the text columns and the label column. Then you need to tokenize the text. So this step involves tokenizing the text in the database, where splitting the text into some kind of subwords. Next you need to create a vocabulary. And this step, you are basically creating a vocabulary for the whole data set. This involves assigning a unique ID to each word or subword in the data set. Then encoding is the next step, where you encode and assign a vector representation to each word or subword in the dataset. Now set up training argument. First, you need to load your pre-trained model, set up some rules for grading. Let's your and then you need to set up your evaluation metrics. So it is basically everything is set up, and it's time to train your model using a transformer trainer. Okay, now you will see how well the training was performed. So we need to evaluate the whole model. And now first you need to save the model, and now you can make the prediction and you can load the model whenever you want to use it. So let's see the different applications. For example, we have a model that can sense if a text is happy, sad, or angry, and how cool would it be to have a model that can answer the question like ChatGPT. So another aspect is text summarization. It's like getting summary of a long story without reading the whole thing. And of course, there is a chatbot and virtual assistant, which come into the next discussion. So like having your personal helper at your hand. In conclusion to the whole discussion, we have learned transfer learning, and then we have implemented it practically in different methods, and we have also discussed some challenges and their applications while the training phase. So that's all from my side. Thank you very much.